Assalamualaikum. This is the presentation for digital communication assignment. Our group title is Dpcm, which is differential passcode modulation. So my group includes of 4 members. For the first one is Abdul Muiz. Then the second one is Muhammad Amirul Shukri. The third one is Muhammad Nur Imran, and the last one is myself, Zarifa Arina binti Zainuddin. For the first part is introduction. So, Dpcm is a process of converting an analog signal into digital signal conversion. Dpcm code words represents the differences between samples, unlike PCM where code words represented a sample value. A differences coding is referred as the basic concept of Dpcm, which is most source signals show important correlation between successive samples. Next, realization of basic concept is a technique in which current sample value based upon previous samples and the actual value of sample and predicted value need to be encoded. Next, Dpcm comparison depends on the prediction technique. The last point is Dpcm could mean expansion comparing to regular encoding.
Hi, my name is Muhammad Imran Hussein and I will present about the literature review. This section will discuss a brief knowledge about the differential passcode modulation (DPCM) and the article regarding it. All the things about the differential passcode modulation is given in a good understandable way. Okay, for the first article that we found is about the differential passcode modulation. This article is written by the Mitra and K. Srimani in 1974. In the article, they state that there are various techniques of coding or approximating the time waveform in a straightforward manner. For example, the passcode modulation (PCM), the differential passcode modulation (DPCM), and delta modulation (DM). These waveform approximating schemes are mostly used in digital speech coding, where speech reproduction is needed with a quality sufficient for commercial telephone system. In DPCM, a distinct advantage of bandwidth reduction for the same value of SNR over the usual PCM SIM is obtained. As for the second article, the title is Differential Passcode Modulation with Entropy Coding. It is written by the O'Neill in 1976. In the article, he states that the communication signal generally contains two types of redundancy. There is redundancy due to the high correlation between signal elements. This redundancy is concomitant with the non-uniform power spectral density. It is removed by the differential passcode modulation operation. Every signal can be conceived as having a predictable part which contains no information and a non-predictable part which contains all the information. Differential passcode modulation discharges the predictable part and encodes only the innovation. There is redundancy due to the signal to be transmitted. For example, the discrete level from the Dpcm system do not occur with equal probability. This type of redundancy is removed by entropy coding this level using a variable line of Huffman code. Moving on with the last article that we gathered is about slope overload noise in differential passcode modulation system. It is written by the Protonetarius in 1967. In the article, he stated that in differential passcode modulation system, often referred to as predictive quantizing system, the quantizing noise manifests itself in two forms, which is granular noise and slope overload noise. The granular noise is essentially uncorrelated with the input signal and has more or less flat power spectrum and an approximately uniform amplitude probability distribution, resembling the granular noise in standard PCM. Okay, why are we going for DPCM? Like PCM, DPCM is comprised of sampling, quantizing, and coding process. But DPCM differ from PCM because it quantizes the difference of actual sample and predicted value. The DPCM uses the common property of PCM in which the high degree of correlation between adjacent sample is used. This correlation is generated when the signal is sampled at the rate greater than the Nyquist rate. As an outcome, the difference between adjacent sample is consists of an average power which is smaller than the average power of the original signal. The encoding of extremely correlated signal in the standard PCM system produce redundant information. Through eliminating redundancy, more efficient signal can be produced. That is all from me. Thank you.
My name is Abdul Ibadur Rahman. Okay, now I present to you about the result. First of all, what modulator, how it works. Okay, the sample signal is XNTS and the predicted signal is X to the power of NXTS. The comparator find out the difference between the actual sample value and the predicted value. This is called error and is noted as ENTS. The predicted value is produced by using a prediction filter, that is signal processing filter. The quantizer output signal EQNTS and the previous prediction is added and given as input to the prediction filter. The signal is denoted by XQNTS. This makes the prediction closer to the actual sample signal. The quantized error signal EQNTS is very small and can be encoded by using a small number of bits. Thus, the number of bits per sample is reduced in Dpcm. So, the equation is EQNTS equal to ENTS plus QNTS. So, QNTS is quantization error. From the above block diagram, the prediction filter is XQNTS. Is obtained by the sum of X to the power of NTS and the quantized output EQNTS. Therefore, the quantized version of signal XQNTS is the sum of original sample value and quantized error QNTS. The quantized error can be positive or negative. So, the output of the prediction filter does not depend on its characteristic. Next, for the demodulator, Dpcm receiver consists of decoder and prediction filter. In the absenteeism of noise, the encoded receiver input will be the same as the encoded transmission output. The predictor undertakes a value based on the previous output. The input given to the decoder is processed and the output is summed up with the output of the predictor to obtain a vector output. So, it means the decoder will reconstruct the quantized form of original signal. Finally, the signal at the receiver differ from the actual signal by quantization error QNTS, which is introduced permanently in the reconstructed signal. So now is the experiment that I have done to prove the Dpcm, that is the image compression using Dpcm with LMS algorithm. So at the figure, it is a block diagram of the LMS adaptive image compression system is shown. It is seen that the image prediction YN is formed in a linear manner at the output of the LMS filter. So the result is we can see that the original image is in the matrix dimension, and visual result for the processing linear image with LMS and Dpcm can be seen, where the first one is the compressed image with the 3-bit pixel LMS, then 3-bit pixel with the Dpcm, continue with the 1-bit pixel for LMS, and finally the 1-bit pixel for Dpcm. So finally, it's an application. Dpcm technique mainly used for speech, image and audio signal compression. And the lastly, this method is suitable for related application of medical imaging such as telemedicine and online diagnosis.
My name is Muhammad Amir Shukri Rahim. I will explain about the part of discussion. From the result we have obtained, Dpcm stands for differential pulse code modulation, a technique of analog to digital signal conversion. The differential pulse code modulation is a signal encoder that uses a baseline of pulse code modulation. Dpcm functionality based on the prediction of the future values of the signal. It has its own transmitter and receiver circuit which contains a predictor filter that acts to reduce the quantization error. The Dpcm works on the principle of prediction. The value of the present sample is predicted from the previous samples. The prediction may not be exact, but is very close to the actual sample value. The Dpcm technique mainly used in speech, image, and audio signal compression. We have learned about the characteristic of Dpcm. From there, it has its own advantages and disadvantages by using Dpcm technique. The advantages of Dpcm are bandwidth requirement of Dpcm is less compared to PCM. Circuit configuration are simplex. Quantization error is reduced because of the prediction filter. Number of bits used to represent one sample value are also reduced compared to PCM by 3 to 4 bits per sample. It provides high signal to noise ratio SNR with less noise and lower bandwidth compared to PCM. For the disadvantages, of Dpcm, the practical usage is limited. In Dpcm, we subtract adjacent samples and code the difference. However, this method is inefficient since they do not adapt themselves to varying magnitude of audio stream. Hence, better results are obtained by using ADPCM, that is an adaptive differential pulse code modulation.
Okay, for the last part is conclusion. Once the analog signal is sampled, the difference between the value and its predicted value is quantized and encoded, forming a digital value. So Dpcm is explained by using 3 articles. For the first article, it states that when the sample at Nyquist rate, it shows a good correlation between different samples. The second article said that the Dpcm will discard the predictable part and encodes only the innovation. And for the third article, it is about the Dpcm as predictive quantizing system. The quantizing noise manifests itself into 2 forms. So the first form is granular noise and the second form is lobe overload noise. So the Dpcm technique is used for the speech, image and audio signal compression. So therefore, the Dpcm is efficient for lossless compression and implementation for lossless or near lossless medical image compression. That's all from us. Thank you.